Okay, I'm the final speaker in this session. My name's Kenny Smith. I'm based in the Centre for Language Evolution at the University of Edinburgh. I'm going to present an experimental study of semantic extension, actually two experiments on semantic extension in a novel communication system. And this is joint work with Josie Borman, who used to be my postdoc in Edinburgh. So languages persist through a repeated cycle of learning and use. And as a result, languages are shaped by biases in those processes. So one way you can think of this is that individuals encounter linguistic data through a process of learning. They form some grammar, some mental representation of how that language works. That grammar doesn't just sit inert in your head. You use language to get stuff done in what Herford called the arena of use. And as a kind of inadvertent side effect of using language for communication, you produce further linguistic data, which might form the basis for learning in others. And you can imagine this process unfolding over generations or in reciprocal interaction between two individuals influencing each other. There are kind of two main ideas guiding our work in Edinburgh. One is that biases in the processes of learning and use are responsible both for fundamental structural properties of all natural languages and also observable historical processes by which languages change. Basically, both of those things are a function of the same process. And secondly, that we can study these processes experimentally and in simulation. Okay, so in this talk, I'm going to apply these ideas to semantic extension. Semantic extension is a productive in-the-moment process for extending an existing communication system to meet new expressive needs. As on a historical timescale, a result of this kind of in-the-moment semantic extension is semantic change, including in grammaticalization. And I'll explain what grammaticalization is in a second. Some people have also suggested that semantic extension plays an important role in language origins. Today, my focus is on the kind of interactional and historical timescales, so I'm not going to talk about that. Okay, so if you have a gap in your communication system, you can make an ad hoc extension to meet your in-the-moment communicative needs. So for instance, if you're a small child with a limited lexicon, you might take one term like TikTok that's used to refer to initially to clocks and watches and extend it to refer to anything with a dial like bathroom scales and gas meters if you let your kid play with the gas meter. It's not just kids who do this, adults will do something similar. So you might extend the term axe to incorrectly cover an ads, or you might label a plumber's cartridge remover as a corkscrew because that's what it looks like. And more figuratively, you might refer to individuals in your environment or things in your environment by their salient attributes to amuse your friends, for instance. And you might make more metaphorical extensions, as in the immortal lyrics of the Backstreet Boys. Okay, so a motivating example, sorry, I should say, these extensions are done in the moment to meet a communicative need, and most extensions just kind of disappear once that exchange is over. But some particularly useful or likely to be made extensions can catch on and become a conventional part of the language. And as a result, words in a language acquire new meanings over time, or their meanings change. And a kind of motivating example of language change that made us want to run the experiment I'm about to tell you about is semantic extension in grammaticalization. So grammaticalization is a historical process of semantic generalization and phonological reduction, which results in the development of functional elements from larger constructions like phrases and words. A classic example, which has happened in English, but also many other languages, is the development of future tense markers from verbs of motion. So modern English has three layered senses of go. Historically, the oldest one is go as a verb of motion. A more recent addition is go as an indicator of intention in the absence of motion. And the most recent addition is go as a pure marker of futurity. So the idea is that these three senses of go are a product of a cyclical process of semantic extension, exploiting shared salient associations. So the story is something like this. Motion has a kind of association with intention, an implicit association with intention. And some uses of go as a verb of motion kind of foreground that notion of intention. And this means this is a ripe association that can be exploited creatively to convey intention. That happens repeatedly, and we end up with this new sense of go as a marker purely of intention. Then this cycle can repeat. Your intentions are usually about your future rather than past activities. In some cases, the futurity of what you're talking about is foregrounded. And again, this means it's a ripe set of material for this kind of extension to become part of the language. So the idea is that shared associations between movement and intention and futurity license reliable inferences, allowing creative usage, semantic extension. With sufficient use, new associations become conventional and can form the basis of further extensions. So we were interested in exploring that kind of process experimentally. To do that, we ran an online communication game. We recruited participants individually through Prolific and paired them in the experiment. We asked those pairs of participants to communicate using a restricted inventory of signals. And the signals are actually geometrical shapes. So each pair got allocated 4 different geometrical shapes. We force people to repeatedly extend the meanings of their signals. So they start off using shapes to communicate about shapes. That's very easy. But then we ask them to extend that signaling system using those same 4 signals to talk about colors, objects, and eventually emotions. And we manipulate the reliability of salient shared associations during the experiment to test the role of those kinds of associations in semantic extension. Okay, so here's what a trial in the experiment looks like. Every trial has a sender and a receiver. This is the white shapes blocks. This is the easiest initial part of the experiment. The sender sees 3 concepts. One of them is highlighted with this green box as the target. So this is the thing you have to convey to the sender, to the receiver. The sender has to pick a signal from this inventory, which are also geometrical shapes. These are the signals. And obviously, if you have to convey diamond and you've got a signal that is a diamond, that's a very obvious thing to choose. So the sender selects this signal. The signal that the sender selected appears on the receiver's screen, and they just have to guess what the target was. And obviously, this is trivial here. After every trial, they get feedback, success or failure. So they do that for a small number of trials to get them started. Then we move to what we call the shapes block. So in the shapes block, the goal is still to communicate shape information. That's all you have to tell your partner is what shape is the target. But kind of incidentally, irrelevantly for your communicative goal, the shapes that you're talking about are colored. Okay, so the signals are always just these 4 black and white shapes, but now the concepts that you're talking about are colored shapes rather than black and white shapes. Okay, but that doesn't matter to your communicative task. You still just have to encode that it's a hexagon. You've got a hexagon signal, so that's going to work really well. So we use this shapes block to make our experimental manipulation. So during the shapes block, participants will either encounter fixed or random color shape associations. So in the fixed condition, every time you encounter a particular shape, it's in a characteristic color. So for instance, hexagons might always be pink, diamonds might always be red. In the random condition, every time a shape occurs, it's in a random color. So hexagons are sometimes pink, sometimes gray, sometimes yellow, and so on. So the idea is that in the fixed, the color of these shapes is not relevant to your communicative task, but the idea is that in the fixed condition, that gives you a salient shared association between color and shape that you can potentially exploit later. In the random condition, you don't have that. Okay, so after you've done the shapes block for a while, you move on to what we call the colored splats block. Here, suddenly you're forced to extend your communication system now to convey color information. So I have to pick a shape to convey redness. If you've got a shared association between, say, red and diamond, then it's pretty obvious how you should do that. If you're in the random condition, you don't have that shared association, and you've got to build it up from scratch with your partner through trial and error. Okay, so that's the first extension block, colored splats. We then do another extension block, again, where they have to communicate about color, but this time it's colored shapes you're talking about. This poses the additional problem that you have to kind of suppress your tendency to use crosses to talk about crosses, because what you need to convey here is pinkness, and maybe the best signal for that might be, say, the hexagon, not the cross. After the colored shapes block, you do an objects block, where you have to convey object concepts, pig, volcano, banana, or city. And we picked those concepts because we thought they had a stereotypical color that made for an obvious way to extend color signals to cover those objects. And then the final block, you have to make a metaphorical extension. So you have to extend your signaling system to talk about emotions, love, anger, happiness, and sadness. And again, we picked those because we thought there was an obvious metaphorical extension that could be made. I should say all the code for the experiment as well as the analysis and stuff is on my GitHub page. Okay, so I'm going to show you participant performance, first of all, so how successful they were at communicating. Performance in the white shapes and shapes block is basically at ceiling, because that's a trivial task. So I'm just showing you performance in the extension blocks. So colored splats, onwards. Each point here is a pair of participants. This is how often they succeeded on the communicative task. Blue points are participants in the fixed condition. Orange points are pairs of participants in the random condition. So what you can see is that people are pretty good at this task. There is, however, an advantage immediately to having those fixed associations between salient shared associations between color and shape. That gives you, particularly early on in the extension block, it gives you an advantage over participants in the random condition who have to figure stuff out by trial and error. Performance increases across the blocks and basically plateaus at the objects and emotions block. What we're actually interested in, though, is not so much performance, is how people extend the meanings of their signals. So we need a way of quantifying extension. So what we do is we just count co-occurrence frequencies between target concepts and signals. And if you want to look at how you extend, say, from the shapes block to the colored splats block, all you need to do is just make a count of how often you use each signal to convey each concept. So say if you're in the fixed condition, every time you see a square, it might be gray, and therefore every time you try to convey this concept, you use this signal and never the others. We can do the same thing in the colored splats block, and you'll notice that these are lined up such that the configuration of the two grids captures the way we expect people to extend. You should take this signal and use it to convey grayness. That means we can take the absolute difference between those two co-occurrence frequencies. It's a matrix of absolute differences, and we can sum it to get a difference score, which in this case is 2.75. And our prediction is that if you're extending in the way we expect you to, then your difference scores should be relatively low. You should basically, these two matrices should be very similar. If you're coming up with a completely new convention at the second block, the difference score is going to be relatively high. We can't actually plot raw difference scores because random matrices have a very low difference to any other matrix. So what we have to do is convert these difference scores to a z-score using Monte Carlo techniques. So what I'm going to show you is plots for the two conditions of how people extended their signaling system from shapes to colored splats to colored shapes, and so on. And what I'm plotting is these z-scores. So if the z-scores are around about 0, that means you're not extending in the way we predict. You're creating a new convention when you move to the second block. If your z-scores are very low, that means very small difference between those two matrices. That means you're extending your signaling system in the way we predict. Okay, so looking at the fixed associations condition, first of all, what we see is that early on in the experiment, most people are extending in the way we predict, yielding these very low z-scores. Slightly unexpectedly, though, when they get to the emotions block, some people extend in the way we expected, using pink for love, say, but lots of people seem to form a new convention for talking about emotions and not extend in the way we expected. If we look at the random associations condition, well, in that first block, by design, these z-scores are around about 0. They don't have any shared fixed associations they can draw on, so they have to form a kind of arbitrary convention for using shape to talk about color. But then after that point, the results look very similar to the fixed associations condition. People extend in the way we expect, and then we also see that kind of formation of new conventions in the emotions block. Okay, so interim summary, people use semantic extension productively in this task. Salient shared associations, as provided in the fixed condition, are helpful, but they're not actually required. People do pretty well in the random condition. But there is a kind of puzzling feature of our results, is that most people prefer not to extend in the obvious way in that emotions block. They come up with a new convention to talk about emotions. It could be that metaphorical extension is hard and people just do it differently. Not everyone gets the metaphor we thought they would make, but it could be a feature of our design that's a little bit odd. What we're expecting people to do is use the signal for pink to talk about love, but the objects block intervenes there. So what we actually do is ask them to take the signal for pink, use it to convey pig, and then use the signal for pig to talk about love. And people people are not into that. Okay, so the way we resolve this is to do a second experiment, and where we make some of those extension blocks different between subjects, between pairs. So everyone goes through the white shapes, and colored splats blocks. So they get that first colored splats extension block. Then they just do one of the remaining extension blocks. So they either extend again to colored shapes, to objects, or to emotions. Okay, so the results for communicative success look basically like what I showed you in the first experiment. It's pretty high. Performance is slightly higher in the fixed than the random condition. But if we look at the extension behavior, it's quite different now between these two conditions. So in the fixed associations condition, people are extending in the predicted way. This is from colored splats to colored shapes, colored splats to objects, and so on. And even in colored splats to emotions, most people are extending in the way we predicted. So this between subjects design kind of resolved that problem with the pig equals love. If we look at the random associations block, it's quite different. Here, people are generally forming a new convention at the second extension block. That's true if you're extending from color to emotion, from colored splats to objects, but also from colored splats to colored shapes. So these guys lacking those fixed salient shared associations seem to struggle even at extending from talking about colored splats to talking about colored shapes. Okay, so to wrap up, people use semantic extension productively in this task, which means it's a potential tool for investigating the interactional basis of semantic change and grammaticalization. Salient shared associations, as provided in the fixed condition, are helpful, including in establishing further extensions. And in our paradigm, as a kind of incidental finding, metaphorical extension is no harder than extension based on more concrete associations. So it's as easy for our participants to extend from the color pink to mean love as it is to extend from pink to mean pig. Okay, thank you. I'm going to monitor the Zoom chat. Any questions from the room or from the chat?
That's really interesting. I have a question that I think has whatever the answer is, it will not bear on your results, but I'm just finding myself curious, which is about whether the generalization is symmetric in the different directions. So going from color of something to the shape of something, suppressing color versus suppressing shape don't seem equally hard. And I'm wondering why you did it in the direction that you did and whether it would matter.
Yeah, so the reason we did it in the direction we did in this experiment, so the reason we go from shape to color is that we thought that was the first thing that sprung to mind, is the way to set up a communication game where the initial step is completely trivial. I guess we could have done that using colored signals to refer to color. Maybe that's a good question. We should probably also have some predictions about which direction is so concrete to abstract should be easier than abstract to concrete extensions. So we have a PhD student, Anna Capron-King, who's here but possibly not in this room, who is interested in those kinds of asymmetries. So that's one of the features of grammaticalization and other kinds of semantic change, that you tend to go from concrete to abstract. So for instance, terms for body parts will often become prepositions. She's interested in figuring out why you get those asymmetries. So it's not something we've tackled in this experiment, but paradigms like this we're going to use to address those questions. Great question, thank you. No, you're good, thank you.
Yeah, this is super cool. So a question I had is, so people have this tendency to form conventions very generally as well, right? And so it seems like when you have this kind of nice kind of association to drive these carryover effects, they're less likely to form novel conventions from block to block. I'm wondering, since it seems like all your associations are like definitely, you know, whenever it's a square, it's always a yellow, or like, you know, whenever it's a diamond, it's always a pink or so on. I'm wondering like how you could push or pull on people's tendencies to form new conventions by making that mapping a little bit more probabilistic, right? Like you maybe like only 80% of the time you could have like a pink diamond mapping on the other. Do you have any kind of thoughts on?
Yeah, that's a really good idea. So that was our intention when we set up this experiment. This particular experiment is ruinously expensive to run. So that's about 400 pairs of participants. It takes about 45 minutes. So it's several £1,000s of participant payments. But the plan is you can in that shapes block, you can manipulate the reliability of those associations. At the minute, we're doing like 100% reliable, as you said, versus completely random. Yeah, it would be nice to do something at a kind of intermediate level. I would expect the results will look kind of somewhere in the middle, but that remains to be found out. And if I can round up some money from somewhere, then we'll run that.
Yeah, because the reason I ask is, like, you know, when you're having those extension kind of conditions, you might still feel the temptation to form new conventions. It'd be interesting to see, like, within the trial structure, like, you know, are people first trying to form a new convention but just giving up and falling on these kind of associations they already have, or you know, are they even trying at all? So I don't know. Very really interesting one.
Thank you. And all the data is online, so if you can figure out a way to operationalize that, you can have a look yourself. Right. Thanks very much, everyone. That brings this session to the end. The Rummel Heart. Thanks to all the speakers.